And for those of you who'd like to go a little deeper, so would we here at the Smash News Network, least busted name in news. So let's talk about the magnetic environment. Stars are deeply entwined in magnetism. It has to do with the way they behave, their magnetic fields, and so on. More on this at a later time, as we'll be releasing a paper explaining the mechanisms underlying the solar cycle. So let's blast through some information about the magnetic environment and sunspots. This is the top view ecliptic plane field plot. And Earth has just recently moved into a North Pole current sheet, shown here in green. There you can see the last image. Earth's orange line here, this is Earth's potential field surface source line, now associated with the solar North Pole, the plasma in between Earth and Sun, oriented to the solar North Pole. So here's the GOES magnetometer over the past 3 days. And you can see some pretty wild spikes here. We are currently experiencing a high-speed coronal hole wind stream. We'll get to it in a moment. First, a line-of-sight ecliptic plane field plot showing the solar magnetogram. I'm expecting some sunspots to rise in the southern hemisphere. So we've got a new sunspot up here that's not even named yet. But in the south, we're expecting some more significant activity. Next, we'll show the coronal hole line-of-sight plot. And there you can see the sun's B field shown in blue lines. Those are the potential field surface source lines of the sun's B field, the field that goes through the magnet, this magnet being the sun. And we've got another trans-equatorial coronal hole rotating in here of North Pole orientation shown in green. Here's the closest star, El Sol, Helios, in 193 angstroms. One of the better wavelengths to look at coronal holes. You can see an M-class flare there as well. Make sure you watch our previous video for some spectacular close-ups, or videos that premiered after this one for additional spectacular close-ups. Next, looking at sunspots. We've got a new sunspot right up here. And as we stated yesterday, the most likely place to see major flares remains sunspot 2929 and 2930. That M-class flare generated from sunspot 2929. You'll see it brighten up there. It looked like a plasma transfer to us. Please leave a comment if you think the sunspots are causing the plasma transfer or the plasma transfers are causing the sunspots. Remember, folks, correlation does not necessarily mean causation. Next, our flare probability monitor. Again, we're going to have a new sunspot named up here. Make sure you check out our bonus features video a little bit after this one. We'll show you a high-res image of that. So there's that M-class flare, the peak flux of that flare, which did cause some high-frequency radio blackouts over the Americas. Happened at about 1740 Universal Time yesterday on January 18th. It did not send any relativistic particles, or if so, just a few. Nothing really noteworthy there on the proton flux. And let's go to the real-time solar wind to see this continued elevated coronal hole wind stream, it certainly looks like. So we may see this rise back up again here. Actually, it looks like a coronal mass ejection strike as we see the phi angle, the BTBZ, the density, the speed, and the plasma temperature all shifting at once. So that certainly looks like a coronal mass ejection strike, sort of during a high-speed coronal hole wind stream. So pretty significant coronal mass ejection strike there. Keep in mind our specialty is forecasting CMEs before they leave the corona, not their trajectory or speed, at least not yet. We're working on it, and we need your assistance to do so, so make sure you press like and subscribe and share. Tell your friends and foes about the channel. Current conditions are very low solar wind density here. Barely 1 proton per cubic centimeter. Okay, make it 2.3. About 2.3 protons per cubic centimeter is a solar wind density. Solar wind speed still quite high here at 614 kilometers per second. Quick side note, for everybody who thinks NASA is hiding data, I would refer you to the Space Weather Prediction Center pages. You can see all those links down there. Those are a lot of links of data and models. So the idea that NASA is hiding data is complete nonsense. Stop refuting yourselves on YouTube and talking out your you-know-whats. I brought up the Aurora Forecast here just because we did have some heightened auroras. This is going to be calming down now as we see such a low solar wind density, although the speed does remain elevated. So we likely to see some more auroral imagery, make sure you follow us on Twitter. We regularly share some great images of auroras and as well as videos of it. So check us out, twitter.com/smashamash. We're also on Getter and on various other social media. You can see some significant intensification there over northeastern Canada. Some fairly uninhabited regions of the world saw some pretty spectacular aurora from that geomagnetic storm. Also, there's a geoelectric field map you can look at, which will tell you the likely induction into things like power grids, pipelines, railroad lines, and so on. The EMTF model, you can read all about it by clicking details. More data not hidden by NASA. That's actually USGS data. Also, the KP index was all the way up to 6 there. A sudden increase in the induced current on planet Earth. That's the KP index is a measurement of global geomagnetism for you new viewers. And let's take a look at the density around Earth's magnetic moment from space. So now you're looking at protons per cubic centimeter. This is just literally density. The scale is only 0 to 4 protons per cubic centimeter. It's showing you high density in dark blue and low density in white. I'm going to let it play through a second time. We usually only show the pressure, but fortunately the pressure has just dropped as a result of that decrease in the solar wind density. So we've got pressure drop coming in right here, and you can see the way that likely affects the geospace. Here's the pressure data that we usually show. It's our other geospace magnetosphere movie for the day. These are 4 hours of data. And this one is magnetohydrodynamic pressure expressed in nanopascals. And you can see those perturbations happening there as a result of that sudden change in solar wind density. Next, Earth's magnetic moment from the ground. Here are the ground magnetic perturbations. We're seeing pulses coming out of places like the western Pacific Ocean. Some significant pulses there out of the western Pacific. And some sort of consistent magnetic perturbations happening there over North America there, around the U.S.-Canada border. We're going to let it play through a second time here because that's some interesting data there. And this shows you the most likely places for induced power issues as well as aurora. We like to tie the variables together so you don't have to. All right, and let's pick up the pace here. Next, a diagram of the solar system from theplanetstoday.com. We're going to advance it 1 week to show you a forecast. There's where things will be in a week as Mercury's swinging past. Here's a star chart we've drawn on the ecliptic and the galactic plane. Those are the yellow and blue lines, respectively. If you're up before dawn, you might see Mars and Venus rising ahead of the sun. Some of the brighter objects visible in the sky. And let's take a look at our coronal mass ejection warning, which continues from the viewpoint of stereo A and the LASCO C3. So the LASCO C3 is located here at Lagrange 1. Stereo A is located here at Lagrange 5. And we brought it back a little bit to show the coronal mass ejection. Some components of this look like they are Earth-directed. So you can see some ejecta on both sides of the coronagraph imagery there, an indication that some of that ejecta is likely headed toward Earth. Most of it will miss Earth to the northwest, and you can see the best way to look at the north-south line would be to look at stereo A. So from that perspective, for you new viewers out there, Earth would be off in this direction from stereo A, and it would be directly behind you from the perspective of the LASCO C3. That's a coronal mass ejection warning continuing. And the likelihood of large flares continues as well. Make sure you tune into our cosmology segment. That'll be premiering later in the day today. There will also be a bonus features video coming out soon. So thanks for tuning in, everybody. Congratulations on realizing the channel exists. Help us out with a like, a subscribe, a share on your favorite social media. If you're a larger channel, come feature us. We'll be more than happy to do an interview with you, bring you on our channel, and vice versa. I've been your host, Dan, a.k.a. Smash, signing off from the Smash News Network, least busted. Name it news.